Hi guys, today we're going to do an example where we find all of the zeros of a polynomial function. So here's our example. We want to find all zeros of the function f of x equals x cubed plus 8x squared plus 22x plus 20. We can note that since our degree is 3 of our function, we expect there to be 3 zeros. Of course, that's not always the case. If there are repeated factors or repeated zeros, we would have less, but we're going to expect there to be 3. So we're going to use the Rational Roots Theorem, and that will help us guess some zeros to check. So we know that rational zeros will be of the form constant term over the leading coefficient. We take all the factors of our constant term, all the factors of our leading coefficient. In this case, our constant term was 20, our leading coefficient was 1 because our leading term was just x cubed, so the leading coefficient is just 1. So it's not too bad. We just have to check these numbers, plus or minus for each one, of course, to check to see if there are any rational zeros. And if you're doing a problem of this type, they're probably set up so that at least one of these is going to be a rational zero. So you have two ways to check to see if a zero or rational number from that list is 0. The first way you can do is just plug it into the function, and if you get a result of 0, then it does work. The other way is just to go ahead and do a synthetic division chart for it. I would suggest doing the synthetic division part because if you find out that a certain number is a 0, then you're going to have to do this anyway to divide out that factor. So we might as well just go ahead and get extra practice on our synthetic division. So let's start with 1. That's always a good start. We just put 1 in our box. We use a positive 1 if we're guessing a positive 1 because we're basically guessing that x minus 1 is a factor. So if 1 is a 0, then the x minus 1 factor would become 0 if in fact the number 1 was a 0 for the function. So you do not change the sign if you're just guessing a 0. You just put that right in the box. So as we can see here, when we do synthetic division, when we have a positive number here and all of our multipliers or coefficients for each term are positive, we're never going to get a 0. We're never going to get any subtraction. So basically, just from this one table, we can throw out all of our guesses for positive numbers. We only need to guess negative numbers because we do need some sort of subtraction here in order to get this back to 0 as a remainder. So that's what we're looking for, is a 0 in this box here. So if we get a 0 remainder, we know that the number that we picked is a 0 for the equation. So let's try negative 1. Bring down the 1. 1 times negative 1 is negative 1. Add in columns. We get 7. Negative 1 times 7 is negative 7. Add in the columns. We get 15. Negative 1 times 15 is negative 15. And we add and we get 5. So we're getting closer. Once we have these negatives in here, then we can actually get subtraction going on, and we can get closer to 0. So let's try negative 2. This one looks pretty good. So bring down our 1. Negative 2 times 1 is negative 2. Add, we get 6. Negative 2 times 6 is negative 12. Add, we get 10. And negative 2 times 10 is negative 20. So we've guessed negative 2 as a 0. So that means that the factor that we're going to be pulling out is x plus 2. So when we factor this, since we know that the number negative 2 is a 0, then when we plug in negative 2 for x, this part will become negative 2 plus 2, which is 0, and it doesn't matter what this part is. So we will write our factor as x plus 2. This is when we change the sign. This part here, this leftover trinomial, is from the coefficients of our answer down here. So This tells us that when we divide our original polynomial by x plus 2, we get x squared plus 6x plus 10. So that's where this comes from. So once we've got our leftover factor here down to a second degree polynomial, we can just use the quadratic formula. If we look at this, we can often skip a little bit of that work, and if it's factorable, then we can factor it, but I can't think of any two numbers whose product is 10 and whose sum is 6. So it looks like our final two zeros from this part are either going to be containing square roots of numbers that make them irrational, or they're going to have i's in them. So let's go ahead and use the quadratic formula to solve this. X squared plus 6x plus 10 equals 0. We write down what our a, b, and c are. It's always a good idea to do that. Limits your mistakes. Plugging it in, it looks like we are going to get a negative number inside of our square root. So our final two zeros are going to be complex. They're going to be containing i's. So here we got the square root of negative 4. We simplify that to 2i. We just take out the negative, that becomes the I. The square root of 4 is 2. We can then separate this into two fractions that we can easily simplify. So it looks like our final two zeros for this function are negative 3 plus or minus I. So we can write them in set notation and just say that the zeros of our function are negative 2, negative 3 plus I, and negative 3 minus I. And that's all you have to do.